Good afternoon, people. So yesterday we asked a problem. One of our activities was this problem here in particular. We have two blocks, and one is 18 kg, the other one is 12 kilos, and they are dragged across the floor by a horizontal force of 68 newtons. We know the coefficient of friction, which is 0.1 for both of them, between the blocks and the floor. So we want to determine what is the tension of the in the rope T, and the magnitude of the acceleration of the system, right? Because this guy is accelerated by a, but this one will have also the same acceleration. So let's draw our problem here. Let's make this big, and let's draw our problem. So we have our two blocks. One is 18 kg. The other one is 12 kg, and they are connected by a rope, and they are, first one is pulled by a force F of 68 newtons. Okay, so now, as because of the principle of action and reaction, this block A, let's call it block A, and this is block B. Block A will pull block B with a tension T, and block B will pull block A with the same tension T. So now they both have the same coefficient. So let's actually refer everything to this, to the center of the block. So we have a friction which is called F mu, let's call it F mu A, where mu we say is 0.1, and as we know that the normal goes up and the gravitational force goes down, frictional force is generally given by mu mg, which is equal to mu times the normal force, where m is A here, mass of A. And then similarly we have for the block B, we have a tension T and a frictional force which is given as mu mBg. Okay, so once we have this problem here, we're going to set up the equations for A and for B. For that, we're going to apply the sum of all the forces equal mass times acceleration, second Newton's law. So equation 1, or let's call it A, for this block, the big block here, is force 68 newtons. We know all the forces to the right, that's what it means, the sum of the forces, and all the forces to the left, minus tension which goes to the left, and minus the frictional force. Mu A is equal mass of A acceleration. And for the block B, we have similarly that the tension goes to the right, is the only force going to the right, the only force going to the left is the frictional force, which is equal to mass B times acceleration. So now we have a set of two equations. So what do we do to know what is the acceleration, what is the tension? What do we do first? As you can see here, if we can add the two equations, and we have minus T and plus T, the tensions are all the same. So if we add the two equations, the T's will go away, and we say we add the two equations, and we have like the force T and T cancels, minus force of friction A minus force of friction B equal mass A plus mass B times acceleration, which is 68 newtons. Let's go get the numbers here. Minus 0.1 is the friction coefficient, times 9.8, which is the gravitational acceleration, and times mass A plus mass B, which we know. Everything equals this thing here. So then the acceleration will be equal to 68 newtons minus 0.1 times 9.8 mass A plus mass B divided by mass A plus mass B. So this equals about 1 point, what's the calculated here? 1.29, let's say 1.3 meters per square second, right? So then we determine what is the acceleration of the system, of both blocks A and block B. So now what do we do? Once we have the acceleration, we can use any of these equations because the rest is known besides t, and so we can determine for the second, for t, we can determine it from this equation, which is easier, which is mb times A plus the force of friction for B. So now we have everything. We have the mass of B, which is 12 kg, the acceleration 1.3 meters per square second, plus the friction 0.1 times 9.8, that's G, times the mass of block B, which is 12 kg, right? And this I calculated here. Well, let's make it 12 times 1.3 plus 0. We always try to simplify. 9.8 is equal, let's calculate to 27, around 27.36 newtons. Okay, this was the process that we need to follow up, where first we go to the equations, all the sum, the net forces acting on A, this gives us this equation here. Then the net forces acting on B will give us this equation here, and we add all the forces to the right of our center reference frame. This is going to be our 0, 0 here, and this point here is also going to be our 0, 0 here, there, right? So all forces to the right minus all forces to the left. That's what the sum of the forces in Newton's second law really mean, right? Times the mass of the object acceleration, which, as everything is dragging as a whole, the acceleration on A is the same as acceleration on B. Okay, and that was the solution to the problem. Some of you got it right, but I was a little bit afraid because I got like 6 solutions. I saw the first 6 solutions and you got all different numbers. Okay, I hope this solved the problem, and you can do these similar problems in a similar fashion, right? You always get equation A, equation B, and you subtract or add the 2 equations to get rid of, you normally have 2 equations and 2 unknowns. So you can either subtract or add the 2 equations depending on what are the inputs. Okay, thank you very much.